Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी +2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु +3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू बढ़े मध्य परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्य करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई के रखिथिबी तमे सर्च करि परिबो ओके थैंक यू। हेलो स्टूडेंट्स, आज रो टॉपिक रे हमें फिजिकल वेपर डिपोजिशन विषय रे पढिबा which is a process involving the generation and condensation of vapor phase species via thermal evaporation, e-beam evaporation, sputtering or pulsed laser deposition, that is laser ablation, and sometimes it is called vacuum deposition because the process is usually carried out in an evacuated chamber having a pressure less than 10 to the power minus 5 torr. Okay, and in this physical vapor deposition, that is PVD process, actually it occurs in a low pressure or high vacuum environment. Okay, and this PVD method actually is used to produce thin films and coatings which are required for mechanical, optical, chemical or electronic functions. Okay, now in this PVD process the vacuum source is either a liquid or a solid. So in a PVD process the material goes from a condensed phase to a vapor phase and then back to a thin film condensed phase. Okay, and PVD variants differ in the methods which are used to generate and deposit the material, and in thermal evaporation, vaporization of source material, it is done through resistive heating. Okay, now let us see the figure of the schematic diagram of sputtering, that is in case of a PVD process, which is a plasma assisted technique that creates a vapor from the source target by bombarding it with accelerated gaseous ions. Typically we take here an inert gas argon plus. Okay, and here in the e-beam physical vapor deposition the material which is to be deposited is heated to a high vapor pressure by bombardment of electrons in high vacuum and is then transported by diffusion, which is to be deposited by condensation on the substrate. Okay, so this is the schematic diagram of the PVD process involving sputtering. So you can see at the bottom we have the substrate holder. Now above this we have the substrate which is taken in form of wafers. Now above the substrate we have the deposited thin film. Okay, now these small dots are your AR plus ions which are actually colliding with the cathode target, right? Now at the bottom we have the sputtered atoms which are forming a coating, so that thin film has been created and deposited above the substrate, right? Now this rectangular portion is the reactor, which is the evacuated vacuum chamber, and finally we have the power supply. Okay, so that this power supply which is connected with this cathode target, right? Now in case of pulsed laser deposition, that is PLD method, here a high power laser, usually it is ND YAG, so this high power laser ablates the material from the target into a vapor, and every physical vapor deposition process is made up of the following steps, which are like: number 1, vaporization of the source, that is the target material, which is assisted by high temperature vacuum or gaseous plasma. Then number 2, transportation of vapors in vacuum or partial vacuum to the substrate surface. And number 3, condensation onto the substrate in order to generate thin films. Okay, now in most of the cases a reactive gas such as nitrogen, oxygen or methane is introduced into the vacuum chamber for changing the chemical composition of the deposited films. But however, no chemical reaction takes place in a PVD process. Right. Now let us see what are the advantages of this PVD process. So number one, the PVD processes are more environmental friendly than the traditional techniques like that of your electroplating and painting. Then PVD coatings are harder and corrosion resistant, and also these coatings are durable. Right. Now coating of any inorganic and some organic materials is possible on a diverse group of substrates by using this PVD process. Now let us see some of the disadvantages or drawbacks of this PVD process. So number one, here the source material undesirably gets deposited on most of the other surfaces inside the vacuum chamber. Okay, then it requires tightly controlled processing parameters. Further, it has potential contamination activated in the plasma and potential contamination of bombarded gas species. Now this PVD process is actually very slow, and also it requires very high temperature and vacuum for its operation. Okay, now let us see some of the applications of this PVD technique, like in case of semiconductor devices such as thin film solar panels, this PVD technique is applied. Then in case of aluminized PET films, here PET means polyester or polyethylene terephthalates. Okay, so you have seen for packaging of food we use the aluminum foil, so in that case also the PVD process are used. Now in case of titanium nitride, that is TIN coated cutting tools for metal working, also here PVD process is used. Then finally, in case of fabrication of microelectronic devices, interconnects, battery and fuel cell electrodes, then with optical and conductive coatings, this PVD process is being utilized. Okay. Thank you.